Okay. All right, let me know if you're able to see my screen here.
Yeah, we can see it.
Great. And then on Zoom, I know you can do these things where you can have the emojis, you can give a thumbs up. You know, some of those kinds of things might make things easier. So look on Zoom how to you know, create a thumbs up or something like that to let me know. I'll sometimes ask to make sure that you all can hear me and that you're following okay. So a little bit of dry and boring stuff first. This is ECE 5550, fall 2021. I just want to make sure that everybody's in the right class and we have the right prerequisites. My name is Amar Basu. I've been here for 10 years, as I mentioned, and I am the instructor for this course. My office is in 3133 Engineering, but you know, this term we will be doing this course primarily online. Now, I'm planning on having exams in person this term, unless there are you know, issues with doing that, like you know, with the whole how bad the Delta variant gets for COVID. But right now I'm planning on doing the courses, the lectures online, doing a lot of the activities online, but having the exams in person. I think that's the plan right now. This course is going to go from today, September 1st, and it'll go till mid-December. So we are actually going to be done with this class, you know, more than a week before Christmas. So, you know, we're going to be going quickly through a lot of material, but you will be done by mid-December. So I think that's good news. Our lectures are scheduled for an hour and 40 minutes, Mondays and Wednesdays. And in terms of office hours, I'm planning on having office hours after class on Monday and before class on Wednesday. And I'm doing this to sort of accommodate people's different work schedules. And so I'd like to actually get a little bit of feedback from everybody right now as to timings of office hours. Does this timing work? Would you like to have office hours right before and right after class, or are there other times of the day, other days of the week that might be better for you?
So this timing works, but maybe right after class would probably be really good, just in case, you know, maybe if I have a question or something like that on the material that was presented.
Yeah,
but this
definitely.
timing works. The timing that you have right now also works.
Okay. So we can keep the Mondays 7:15 to 8:15 after class for whoever needs help. And if you know, if no one needs help, then I'll probably sign off earlier. The Wednesday, does anyone need an earlier time? Say Wednesday before class, or does everyone prefer to have the office hours after class? Maybe let's just have a since there's only 5 folks, let's just go down the line. Like
yeah, either one works with me. I'm fine with how it is, or yeah.
You're okay with before or after class? Great. And Prakash, how about you?
I prefer after.
You prefer after class? Okay, no problem. I think Melvin said he preferred after class as well. And Corey, how about you?
I think both times are good. Yeah, just in case there's, I guess, any questions before a test or homework, it might be good to call in earlier.
Okay. Yeah, that sounds good. So I think before we have exams and things like that, I'll try to arrange some kind of office hours. Maybe I'll just have the office hours before class that particular day to address any questions that we may have for exams. And Melvin, you mentioned after class you prefer?
Yes.
All right. And Ali, how about you?
I'm good either way, but Professor, regarding the exam, I can't do in person because I'm not in the United States right now.
You're not, oh, I see. You're not in the
Yeah.
United States right now. Okay. Will you be back during the exam times? Which will be the first exam will be October.
I don't think so.
Okay. Well, maybe we can make special accommodations for you, Ali.
Okay, thanks.
Yeah. So we'll figure that out. Okay. So in terms of logistics, then we're gonna decide to I will basically stay after class on our lecture days to address any questions and I can probably stay at least for, an hour after class to answer questions for folks, and just to go over other material. If there's homework that we want to go over, I'm here to help you do that. We've spent the last almost 2 years now, like in this pandemic, and just getting used to doing everything online. And I found some things are very convenient, like things like, being able to do classes from home, being able to, I actually do some work with a startup company, so I'm being able to teach classes remotely. That's nice. But I think that one of the challenges really is that getting sufficient engagement with students, like working together on homeworks and things like that. So I want to try to do that through the office hours. Okay, so I encourage you to ask questions and whatever you're having trouble with, and I'm happy to go through those questions. All right, so in terms of the catalog description, this is what this course is going to be about. The bulletin says this: the physical basis for optoelectronic properties of solids with particular emphasis on semiconductors. Basic principles associated with solid state devices, intrinsic and extrinsic semiconductors, behaviors of PN junctions, bipolar and field effect transistors, and computer-based simulations of device characteristics. So within this course bulletin description, I think that if there's two sets of things that we're going to do in this class that I want you to understand, is on one side, we're going to build up a fundamental understanding of semiconductor physics. Okay, and if you've taken a course in semiconductor physics before, there's a very good chance that there's going to be a lot of overlap with courses that you've taken before. That's the first portion of the course. The second portion of the course is going to be about different types of devices that we use very commonly. We're going to start off with the diode, and then we're going to talk about the MOSFET, the field effect transistor, and then time allowing, we are going to talk about the bipolar transistor and the diode. I'm sorry, not the diode. Things like solar cells and photovoltaics and LEDs. Those things, of course, they're super important. And I have a whole slide deck talking about the importance of some of these different types of devices nowadays. Okay, so a little bit expanding on some of the course topics. We want to have a graduate level fundamental physics understanding of electronic devices. So in other courses that you've taken, you look at the MOSFET as sort of a black box. You have the equations describing the MOSFET, and in this class we go into the details of how MOSFETs are made, what the model is for that, and why does a MOSFET behave in the way that it does. And this is important in your career as electrical engineers. Okay, so we go into the physics that underlie the devices, and then we talk about the devices themselves. So by the end of this class, I want you to have a good idea of how these devices works. I want you to have a good idea of how some of these devices are simulated. One of the new things we're going to do in the course this term is COMSOL simulations, where we do semiconductor simulations, so you can understand how electrons flow through the device, how voltages develop, electrostatic fields develop in these devices. And that's one thing I'm very excited about. The university just received a license for COMSOL for teaching the semiconductor aspects. So we are planning on using that this term. So you have some experience with device simulations. And then finally, I want you to have sort of some understanding of the ongoing state of the art research in the area of semiconductor devices. Why do we want that? Because the semiconductor field is changing so quickly. And it's important that, I believe it's very important that to have a growth mindset. As an engineer, it's important to have a growth mindset, meaning the type of mindset that regardless of where you're at and where your understanding is, you always seek to learn more. It's so important. I really believe that's what separates the average engineers from the really good engineers. Okay, so part of our course project this semester, which we've done every year for the past several years, is to have a project where you and some teammates are going to do some research and a literature review on a emerging modern contemporary topic within solid state electronic devices. So this also gives you a chance to do some team-based projects. Okay, and in terms of learning objectives, now just keep in mind a lot of this stuff is just going to sound like gibberish if you haven't taken the course. Melvin, you have a question?
Hey, yeah, sorry, I didn't want to interrupt you, but
Oh, no
so
problem.
would things like FinFETs, like for the project, would that be okay? Because I know that now as kind of technology is scaling, we're going over to FinFETs, and I believe there's also another type of technology that I actually want to learn more so about myself.
Yeah.
But maybe we'll get into that a little bit more later. But I was just curious.
Oh, absolutely. Yeah, FinFETs. Students have touched on FinFETs in previous semesters, and you are more than welcome to do your project on not just FinFETs, but new radically new transistor designs. And that itself is a great example of an extremely important area of semiconductor devices that is contemporary. It is driving the growth of semiconductors, and it is driving the speed of the phone in your pocket, quite frankly, Yeah. So I really like that your motivation to learn about an area, because here's the truth, right? At universities, we try to make sure that we cover our bases. And in order to cover our bases, we teach a lot of the fundamentals out of textbooks. Textbooks are by nature, they're like 4 years old, 5 years old. They cover material really comprehensively, but they don't cover the latest and greatest, right? So that as a graduate level class, what's important is that you touch a little bit on the latest and greatest, especially in the areas that you personally are interested in. So Melvin, like the example that you gave, you personally are interested in FinFETs, you personally are interested in new types of MOSFETs or maybe switching devices, and then that's the thing that you can explore. Someone else in the class, let's say I'm picking a random name, Corey may be interested in photovoltaics. Clayton may be interested in GPUs, there's so many different topics. I'll touch on a few of them in today's and Monday's lecture. And I hope from there, you'll have some ideas on what you could explore further in a cross-course project.
Thank you.
Yep. Okay, so if any of these things seem like gibberish right now, don't worry about it. But at the end of the course, these are the things that you should be able to do. You should be able to define and describe semiconductor materials, different types of materials that are out there. We'll talk about column 4 materials, column 3-5 materials, and so on. I want you to have a good understanding of crystal lattices. So things like the basic cubic structure or the diamond lattice that's common in semiconductors. The importance of periodicity in developing semiconductor-like properties. Crystal planes, crystal directions, and eventually the diamond lattice. This is the important one. This is the type of lattice that's used, or that column 4 semiconductors have. Silicon forms a diamond lattice with other silicon atoms. This first line item and the second line item here has to do with the physical structure, the atomic structure of silicon. The second item here is describes semiconductor crystal growing methods. Okay, so atomic structure, very important. Atomic structure determines mechanical properties, like something like Play-Doh versus concrete. The atomic structure of Play-Doh is different than concrete, so that's why it has different mechanical properties. Similarly, the atomic structures of materials determine electronic properties as well. It determines whether something is a conductor or a non-conductor or a semiconductor. So we want to understand the relationship between atomic structure and physical properties, electronic properties. Okay, so we're going to go into calculating the physical quantities using classical and quantum models of the atom. Classical physical quantities meaning like things like conductance, like the resistance of a material. We're going to talk a little bit about the bonding force, about the energy band diagrams. Energy band diagrams are the language of solid state devices, solid state electronic devices. We'll talk about the differences between metals, semiconductors, and insulators. We'll talk about the differences about direct and indirect semiconductors. Then we'll get into charge carriers in semiconductors. So there's two types of charge carriers, electrons and holes. Both are super important in being able to carry electrical charge. Now, one misconception many people have is they think electrons flowing through devices, that's electricity. Electricity is electrons flowing through devices, but that's only half correct because there's another type of charge carrier in semiconductors called holes. And so when we try to understand current flow in semiconductors, we have to consider both electrons and holes. Both can contribute to current flow. Okay, we'll talk about a concept of effective mass that has to do with how heavy these particles are because they affect how they move through the devices. We'll talk about intrinsic versus extrinsic materials and the Fermi-Dirac function. So there's an important concept in semiconductors called doping. And doping, if you've taken a class, you know what that means. If you haven't taken a class in semiconductors, you might think doping has to do with drugs, and it doesn't. It has to do with changing the properties of a semiconductor material to make it more or less conductive. The Fermi-Dirac function is a way that we can predict how doping will change the conductivity of a semiconductor material. All right. Okay, then we'll get into more physical models, electron and hole concentrations, because electricity is determined by the flow of electrons and holes. So we're interested in how many holes do we have, how many electrons do we have in the material, and then we're interested in how fast they move. So this bullet point here has to do with how many electrons and holes do we have, how many charge carriers do we have. The second bullet point here has to do with how fast do they move. So drift is basically electrons and holes moving through a semiconductor material due to electrical and magnetic fields. Okay, and so we're going to look at phenomena that causes an electron to move fast through a material or maybe causes it to slow down. So it turns out like when electrons and holes move through semiconductor materials, they actually bump into things. They bump into other atoms. And the more they bump into other things, it slows them down. And when they get slowed down, that's what defines a resistive material. It's resisting current flow. On the other hand, if an electron or hole moves through a material without bumping into anything, then it just moves very easily through the material. Okay, that in essence is what determines the resistance of a material. Okay, so we'll talk about other other phenomena that happens with charge carriers like diffusion, recombination, generation. And these turn out to be very important. Generation and recombination are very important to solar cells. So the whole field of photovoltaics is very important right now, with the climate change and the energy crisis. The beautiful thing about semiconductors, and many of you know this already, is that if you shine light on a semiconductor, it actually creates charge. And photovoltaics not only create charge, they also create current. So there's an infinite supply of energy that we have just from the sun. And semiconductors are the link between this infinite supply of energy and electricity, which we use every day. It's quite a beautiful concept. So we'll talk about recombination, generation, and relate that a little bit to solar cells. Then we'll talk about methods for fabricating PN junctions in semiconductors. Manufacturing semiconductors is key, so important. If we didn't have scalable manufacturing processes, we would not be where we are today in terms of the electronics world. And then the last one is we're going to talk about the operation of the mighty MOSFET, the field effect transistor. Okay. Show of hands, how many of you have heard about the MOSFET or know what a MOSFET is? You can put your hands up if you're able to.
I've heard it, but I kind of forget what it means. So.
Okay, no problem. no problem at all. So a MOSFET is a metal oxide semiconductor field effect transistor. Every computer chip that you buy, a typical computer chip that goes in your phone will have more than 1 billion of these field effect transistors on there. And they are what they do digital communication. Digital computation. They do, analog processing for wireless communications. They do everything. A single computer chip, a single advanced computer chip will have more transistors on it than there are people in the world. It's crazy. So it's a very important device, and we spend a lot of time on that. Okay, if we have time in this class, we'll talk about the bipolar junction transistor, which is less frequently used, but it's still an important device. And or we may opt to talk about optoelectronics instead, LEDs and solar cells. Okay, the ABET outcome coverage, I don't want to spend too much time on. I'll just go through it relatively quickly. What I want you to get from this, when we're talking about ABET outcome coverage, is these are general principles. These are general principles or as general skills that an engineer would want to know. Okay, ABET is is responsible for accrediting engineering programs throughout the country, and they've come up with a set of objectives that they would want graduating engineering students to know. And these things are not specific to any one class. They're more general, general skills. So I'll give you some examples. An ability to apply knowledge of mathematics, science, and engineering, an ability to use techniques, skills, and modern engineering tools necessary for engineering practice. So you can see this kind of stuff relates to any class. So, as just a fun thing, just think about like when you take your classes at the end of the semester, you want to ask yourself, well, did I learn how to apply math, science, and engineering tools or techniques to practice as an engineer? You may never practice as a semiconductor engineer in your career, and that's okay. But did you learn the tools for practicing as a semiconductor engineer? Or better yet, did you learn the tools, or did you learn about how to think as an engineer? Even if you don't touch semiconductors in the rest of your life, did you learn how to solve problems? Did you learn how to communicate effectively? These are like general skills that ABET wants you to have. So some of the things we're going to be doing in this class to help build these skills are as follows. So we're going to talk about the principles of semiconductor devices, and we're going to be using principles in mathematics to derive some of the important relationships. One of the things we're going to be doing new in this class is modern engineering tools. We are going to be looking at how can we employ simulation tools, modern simulation tools to simulate semiconductor devices. All right, second item here is ability to design a system or component or process to meet the desired needs within realistic constraints, things like economic constraints, environmental constraints, and so on. What we're going to be doing in this class, we're just going to touch on it, is that we're going to talk about the 3 different devices, the diodes, the MOSFETs, and if we get to it, the BJTs or the LEDs, photovoltaics. So for each one of those devices, we're going to talk about what kind of performance do we want about these devices? Performance criteria like power consumption, like resistance, like size and cost. And so how do we design a particular device to meet those criteria? It turns out, a diode, there's a general concept of a diode. If you want a high power diode, you might design a diode with a very large area so that it can support a lot of current. On the other hand, if you're designing a diode for high-speed communications, like photodiode applications and optical fibers, in that case, you want to make the diode pretty small because otherwise you'll end up having a large capacitance, which would slow down the detector. Okay, so there's the same device but designed in a different way to meet certain applications. So this is something we want to think about. All right, and then these items here: ability to communicate effectively, knowledge of contemporary issues, a broad education necessary to understand engineering solutions, and then a recognition for an ability to engage in lifelong learning. This is something that I mentioned to you before. This is so important to me. Growth mindset. And the idea of like always learning new stuff, regardless of where you're at. I do this myself all the time. I try to take classes. Over the summer, I was taking a statistics class because I realized I wanted to learn a little bit more about, some of the statistical models that are used in data science. I tried reading up on like what's going on in the semiconductor industry because I'm interested in just keeping up to date with the field. And I personally think lifelong like learning is fun, it keeps life interesting. So you just otherwise just doing the same things day in and day out, learning new stuff kind of like makes life interesting in my opinion. Very important for engineers. So we can't we can't like cover all these things 100%, but what we can do is just we have a course project here, and this course project is going to be on a topic that you research on your own with a team member, and it's going to be related to solid state electronics. And then you're going to present you're going to do a presentation on it, and you're also going to write a literature review. So something like like an 8-page paper or something like that, with the help of another student. Okay. All right. So this activity will help you kind of get in the process of starting to read the literature, read and understand the literature, and then communicating that to other people. This will also teach you some of the contemporary issues in the area of your interest. Moving on to textbooks and other resources. We have a course textbook, but I have here that it's optional. In the past few years, students have said they can get by with my notes. My notes are pretty comprehensive in the sense they have everything that I expect you to know for the exams. I know textbooks can be kind of expensive, so it's not required. Now, that being said, sometimes some students prefer to have the extra textbook because let's say you don't understand how I'm explaining the topic, but you think that Streetman and Banerjee do a great job explaining a topic. That's fine. My goal is that you by the end of the term that you understand the material. Some students like the way that I explain topics. I like to explain things from a very a conceptual level, and you try to give like a qualitative feel for something, before jumping into all the math. That's my style. The Streetman and Banerjee style is they go, it's very academic, step-by-step, lay out the equations, derive the equations. So if that type of approach is preferred, you're more than welcome to use the textbook. Another helpful thing about the textbook is that you'll have more practice problems if you'd like to do them. Yeah, Melvin, go ahead.
Yeah, so actually your videos are actually extremely helpful. Yeah, I actually took the 4570 class before.
Oh, you did? Okay. Great.
And I think at that time, I think you were on a sabbatical.
Mm-hmm.
And I actually watched every single one of your videos, and they actually I actually got a really good understanding based on your videos, the microfluidics and bioinstrumentation lab. Is that
Yeah. So you looked at the course lectures on ECE 4570, right?
Yep, back when I was doing my undergrad around 2017, somewhere around there.
Oh, great.
Yeah, it was very helpful. But with that in mind, I see you have some that are for 5550 as well. Could that also take the place of the Banerjee book? Because I also have the Banerjee book, but the Banerjee book is extremely difficult to read.
Yeah, some students feel that it is, yeah, and it goes into a lot more detail on some of the topics, so it's a good reference to have. But like I said, for the purpose of this class, just like passing the course and understanding the material, you don't need to have the Streetman book. You can go by my my lecture notes and the videos.
Okay. Thank you.
Yeah, by the way, I have in the past, I've posted a lot of these lectures on YouTube, and you can probably find them. Melvin, since you've taken 4570 before, I think you'll be happy to know like that you're going to know a lot of the material in this class. So it might make the class easier for you. there's
Yeah, I
a
think
good
I'd be
deal of
familiar.
overlap of 4570 and 5550.
Yeah, I believe so. Actually, I'll be taking my qualifying exam, next semester. So it's kind of like, I think this is one of the topics. So I'm
Oh,
thinking that,
excellent.
it's good to have like a refresher on it.
Definitely, yeah. And for the other students who are wondering what the qualifying exam is, that means Melvin, you're doing a PhD in our department, right?
Yes.
Awesome. Who are you working with, by the way?
Dr. Hawari.
Oh, excellent.
Yeah.
Yeah.
On the neural networks.
Oh, excellent.
Actually, CMOS implementation of neural networks.
Oh, that's great. Great area to be in.
It's very interesting. Very interesting.
Yeah.
I love it.
Fantastic. Yeah. So for everyone else in the class, like our PhD program, most PhD programs require you to take something called a qualifying exam. That's typically taken at the end of the first year or sometime during the second year during the PhD program. And it's a long, it's a long exam where you have to demonstrate proficiency in, 3 core areas of electrical engineering. So you can choose which areas you want to demonstrate proficiency in, but this class, it's geared towards preparing some of the PhD students for that qualifying exam. And of course, it's also geared towards, graduates and advanced undergrads in just learning this fundamentals of solid state devices. As I mentioned, if you've taken 4570 before in our department, you're going to see that there's a lot of overlap. Okay. So moving on here, textbooks and other resources. We have this course textbook. There's a bunch of other popular textbooks in semiconductor devices, Puree, Simon Say, and then the Sing semiconductor devices. If you find, like I said, if you find that one person's explanation doesn't make sense and you look at another person's explanation, that's a good skill to know as an engineer, or just as someone who's liking to learn different things. There's also, I have my online lectures that are from previous courses. There's a whole bunch of nice semiconductor courses online nowadays. OCW is open courseware sponsored by MIT. There's a nice course on microelectronic devices here. EDX has one, Coursera has one. There's another one here too that I put a link to. So I found some links that I liked how the material was presented. So, keep that in mind. It's always good to have different explanations of the same topics. It's a pretty standard material. So hearing how different people explain it will give you different people's perspectives on it. The final thing I'll say is, online sources like Wikipedia are also a good place to look up information. If you look up MOSFET on Wikipedia, you'll find more information there than we may even end up covering in our MOSFET module. It's very, very detailed. But the reason for maybe taking it in a course is because it's presented in a way that's easier to understand. We can have discussions, and sometimes, online sources, you can't verify their accuracy, so you have to be a little bit careful about that. On the whole scale, I imagine that Wikipedia is generally it's pretty good, especially about standard topics, because there's always people looking at it, and if they see a mistake, they fix it. Okay. So, these references are there for you if there's a certain topic that you want to just don't quite get the way that I'm explaining it. Last but certainly not least is, if you don't understand something, I'm here to help you learn. That's my job. So by showing you these other resources, I'm not saying that go to these first and then come to me. No, you can, however you prefer. If you'd like to talk to me first, I'm happy to do that. If you don't even want to bother looking at these and you just want to have me help you figure things out, I'm happy to do that. Okay, just putting things on here as just so you know what else information is out there. Okay, in terms of posting online lectures this time, since we've had Zoom available at Wayne State, I haven't posted the lectures on YouTube, but I'm considering I might do that. So if you have any issues with lectures posted on YouTube, please let me know. The reason I sometimes like doing that is because I find that there's students all over the world that, you know, they want to learn about a topic and they just don't have the ability to do that, or they can't afford to take a class, but they want to, you know, learn about it. So if, you know, for us, like we're all taking this class, and if I can just take our lecture recordings and put it online, you know, that it's very easy for me to do, and that's something that can be very valuable to someone. And honestly, I've actually I get emails all the time from students in India, in Iran, in Bangladesh, Indonesia, like just random places in the world, like, oh, thanks a lot for posting the videos. It helped me understand a topic. So I like doing that, but I will respect students' privacy first. If there's any reason why a particular lecture that you would like to wipe a part of it or all of it, you know, please do let me know. All right, attendance. So fortunately, this class is online. And so if you have, you know, personal or medical reasons that you have to miss a class, the lectures will be recorded. But there's, you know, I'm limiting the absences to 3. And if you plan to be absent more than that, please let me know or talk to me about that. The reason for that is as follows. You know, I like to give you guys as much flexibility as you need. You know, having this online course, part of the reason I was doing it online is because I know that a lot of our graduate students are working full time. And so saving a trip to drive down to Detroit makes things a little bit easier. In general, Wayne State University and other universities prefer to have in-phase person-to-person classes. Obviously, the last, you know, because of the pandemic, a lot of our classes are online right now. But, you know, that being said, one of the challenges with online courses is, you know, engaging everybody. You know, like take this lecture, for example, you're all listening to me just blab on and on about, you know, policies. This one, you know, we have to do it, if just have stuff to cover. But I want to make things as interactive as possible when is possible. Obviously, when we're going through lecture materials, I end up doing most of the talking, but I'll stop for questions. I want to get your feedback. If there's something you don't want to that you don't understand and want me to explain in more depth, I want that, like, sort of, you know, feedback to happen. I prefer that happen right away. Otherwise, like, you know, otherwise there's so many, you can take online courses where you just go and watch videos, you do some assignments and turn them in. Nothing, you know, nothing wrong with those. In fact, I take a lot of those myself, but it's so much nicer to have some interaction with the professor. Even for me, it's nice to be able to interact with you all. The learning happens in a different way, like when there's interaction, right? Even better if we can do it in person, but you know, even doing this online, I want to have that interaction. I think it's important for us to get to know one another. It's important for me to know exactly what you're not understanding so I can help you learn things quickly. Okay, so that's why I want to have you in class. So if you are going to be, if you're going to miss a class, let me know in advance. 3 absences are allowed for documented personal medical reasons. Exam dates. And exam dates, attendance is mandatory. Okay, so makeup exams, I can work, especially since we have a small class, there's only 5 of us. We can sort of, if there's a conflict, we can make sure that everyone's available on the exam date. So one of the things I want to do in the next week is make sure that we're all, like, locked into an exam date so we can take the exam at the same time. So I'm going to show the course calendar in a little bit. So keep that in mind, that just make sure you keep the exam dates open if you could. So in terms of grading policy, there's going to be a few aspects to this class. We're going to have 3 exams, each is 20%. And those exams will generally be during class. Well, the first 2 are going to be during class time. And the last exam is going to be during the final exam period. I'll put that up on the course calendar. There's going to be a final project I mentioned earlier where you're going to write a paper and do a presentation on a topic, a contemporary topic of your choosing. And then there's also going to be online quizzes and short assignments. So the quizzes, I just started this last term. It's just a way to, make sure you're not falling behind with the material. They're short online quizzes, generally multiple choice. You'll get your feedback on those quizzes right away. It's just a way to encourage you to keep up with the material. And if you find that you did this quiz and some things didn't make sense to you, you can come back during either office hours or even during class and say like, hey, Professor Basu, this doesn't make sense to me. Can you please explain? And it'll just make sure that we're all keeping up to date. This class is, like many engineering classes, is very comprehensive. Comprehensive in the sense that, or cumulative, I should say. Cumulative means that in order to do chapter 4, you need to understand everything in chapters 1, 2, and 3. So if you fall behind, it makes learning more difficult on the stuff that you're currently doing. So then you end up being lost in that lecture, and then that's not like a really efficient use of time. If you want to use your time most effectively, it's best to like be up to date on the material so that the current lecture you're listening to, you're able to follow it because you already know all the background material necessary to follow it. And that way, you're using your time, your valuable time, the most efficiently as possible. Okay. The last 5% is for our attendance and participation. By participation, I mean like, during class, I will have, sort of stopping points where I ask questions. Maybe we'll have like, where you can have like a multiple choice answer. Maybe it'll just be something that you calculate. Maybe you'll share how you did, your homework, a homework problem. Okay, so just getting that interaction with us, I think, is very important. Otherwise, literally, it's just watch video, do homework, do exam. And, it's not really the best way to learn. There's been multiple studies showing that like interactions improves learning quite a bit, improves everybody's knowledge. Policies governing the final exam week schedule. If you happen to have more than 2 exams, let me find that. Yeah, if you have more than 2 exams more than 3 exams in a 72-hour period, I believe you can request a makeup exam. All right, so I'll show you the course calendar in a little bit. Grading scale, typical grading scale. I always put here subject to change because as many of you know, in my class, I generally will do some kind of curving at the end. The reason why I have this grading scale up here is because if you get a certain numeric score, let's say you get an 85, okay? If you get an 85, you are guaranteed at least a B+, at least a B+, okay? Now, if I curve the class, and I generally like curving is done at sort of my discretion, what I do is I look at the scores, the distribution of scores, and they generally will, clump into different regions. And so I give, the top group will get A's, the next group will get B's, and kind of so on. So that being said, if you get an 85 in the class, you are guaranteed at least a B+. And if the curve helps you out, you might get bumped up to an A-. Okay. What will not happen is if you get an 85, the curve will never bump you down to like a B or B- or something like that. It will only help you. Okay, and that discretion is done at the end of the term. But you'll have a little bit of an idea of that when I give you the averages of the tests. So if I tell you like the average of the test is like it's a 75, and then you got like an 85 or 90, well, that's good because you're probably more than a standard deviation above the mean. So that means the curve will probably help you out. Okay, so going on to cheating. This is one area that I more or less have like a zero tolerance policy. If if I see that you are cheating on an exam, or I see that you've plagiarized work from other people, you will receive a 0 in the exam, and a 0 in the exam typically will mean that you'll end up getting a 0 in the class, because each exam is 20% of the class. So losing one, getting a 0 on an exam will put you in a precarious position in the class. Okay, now this happens, the person who, both people who accepted help from other people and people who gave help to other people in an unauthorized manner, both will be penalized. This is really important. Some of you who've gone to undergrad in our department know that, there it happens, like students are like trying to get things, done in a short amount of time, and I guess desperation sinks in and you end up just doing this. It's not the right way to go. Like you're better off like spending the time learning the material, or you're better off like if you need to take the class again, taking the class again. Academic dishonesty is something that I have very strong feelings about, because you're not just cheating yourself, you're making it's something that's unfair you're doing. It's unfair to the rest of your classmates. It's even unfair to the person teaching, because I spent a lot of time like trying to make exam questions fair, equitable, and relevant to the course material. I often like will I end up making at least like I make up new test questions every year. Okay, sometimes I use questions from the past, but I have a policy that I'll try to come up with at least like several new questions per year. So when I see students like not cheating, it's not good. As a professor, I don't like it. And so I will, any type of cheating that I find, I will, give a 0. And I've had different ways of like finding out that people cheated. It becomes very obvious to me when I'm looking at exam papers. If I see that, if I see that the student doesn't really understand the material, yet they're getting the correct answers, you can tell, so even if you're very careful about things, about hiding things and whatnot, like I can usually tell if you don't understand the material well and you're doing things that don't make sense. Okay, so just don't do that. In the past, I've had to give 0s on exams. I don't like doing that because I don't like putting students in a bad position, but our integrity policy requires us to do that. Okay, enough on that soapbox. I think you understand this something that's very important to me. Now on to Canvas. I don't think I need to spend all that much time on Canvas. We have this very nice tool. So if you go to your Canvas site, the first thing that's going to show up here are the announcements. So I will post announcements here, and the announcements I think will go to your emails too. And I just want to double check. Have all of you been getting emails about the course?
Yes.
Yes.
Okay, Clayton, Melvin, awesome, Corey, Prakash, good. So I have a Zoom link here. And it seems like there's going to be a single Zoom link that's used for all the courses, all the meetings. So if you like bookmark this, you should be able to go to that for every meeting. There's 2 links here. One is a calendar link. So if you download this file, it'll load up our meeting times into your iPhone or Android calendars. So you can, have that in your schedule. And then this is a link to actually go to the Zoom meeting. So if you have any problems with that, you can also dial in with phone. if you happen to have like poor internet access for whatever reason or another, but of course you won't be able to see the video if you do that. I obviously will much prefer that you join the Zoom meeting so that we can have all these interactive features as well. All right, so we have our Zoom links here. Other announcements will be posted here as well. You can look here. This is not available to you yet, but I'm going to post assignments here. So things like small quizzes. You know, more on that as we go. If you go down to modules, modules is where you're going to have all the handouts and all the lectures and even links to the lecture recordings. So here you can see that we have like the module 0, the lecture notes have been posted here, general information about the course posted up here. Okay, like the course calendar and the syllabus. We'll go over that in a second, and the notes. One thing I want to ask everybody is I have been putting the notes in this format, which is 2 slides per page. Now I want to see if how many people prefer this format and how many people prefer just 1 slide per page in a landscape format.
I like the 2 slides per page.
Okay, Clayton likes 2 slides per page. Okay, Corey?
I second that.
Okay. Prakash, Melvin?
I think overall it should be okay, but I'm not sure how you you know, because I know that some slides will have probably quite a few mathematical equations.
Oh, yes.
So I'm not sure if those will be kind of condensed, especially if I would like to print them out or anything like that. But otherwise, I mean, 2 slides a page should be fine.
I think for the most part, the equations that I have on the slides are I think they're pretty large. You know, they're pretty
Okay.
large on the slide. So even if you shrink them down, they should be okay. Now
Okay.
that being said, if you if any printout that you make, if you find that the lecture notes are like, if it's too small, I'll upload like a second upload with 1 page
Okay.
per 1 slide per page.
Understood. Thank you, Professor.
So for online, you know, you can zoom in, you know, the lecture slides with equations, you'll be able to zoom in on and things like that. But printing out, I get it, understand. So in general, I will generally have the lecture notes posted beforehand. So for those of you who are like taking notes electronically and like using a tablet or something, you can write right on there, or if you want to print them out, you can do that. My goal is to have them up like at least 30 minutes before class so that you can print them. Okay. What else? So the syllabus, there's nothing really going on the syllabus page other than the lecture times here. Going down to Zoom. Okay, if you go to Zoom, just like you did today, you can go here and just join the lectures. I have these buttons to delete the lectures and start and end because I'm the instructor, but you'll have the links to be able to join the lectures. There's also going to be a link to cloud recordings. You'll see that the cloud recordings will generally show up about 24 to 48 hours after class. Okay, and those recordings will be there for about a year, I think, and then after that they get deleted. If we want to keep them longer term, then I will just download these recordings and post them on YouTube. How many is it people that prefer YouTube over Zoom, or is it fine to just watch the cloud recordings here?
I think it's fine to just keep them there.
I think it's
Okay.
fine as well.
Okay, good. Yeah, you'll be able to see them show up soon. Okay, so that's about it in terms of Canvas. The assignments, you're going to be submitting your quizzes online. You're going to submit your simulation assignments online, and you'll also submit your course projects online. Now with the course projects, like with any written assignment that you've probably done at the university, we have a plagiarism checker. So when you're writing your course projects, remember that you must write things in your own words. Don't copy and paste things from other papers. Don't cite, don't cite things. Don't include stuff from other papers without without proper citations. We'll go into the details of that when we talk about the course project. Okay, so let's get into the course calendar here. I have a PDF version of the calendar. So a little bit of this it might change a little bit in the first few weeks, but I'm going to do my best to kind of stick with them. And I'll kind of I'll show you what the course topics we're going to do, and also the project, the ongoing course project during the semester. So today we did the syllabus. We're going to do introductions, student introductions. Everyone can introduce themselves, and hopefully we'll start on module 0. If not, we'll start on it after Labor Day. So no class on Monday, Labor Day. Hope you all enjoy awesome September weather, my favorite month before things start getting cold. Next week, I will be out of town working with a collaborator. So Wednesday's lecture, I'm going to be doing remotely, but it's just going to be the usual lecture we'll be on Zoom, and I'm going to talk to you about the motivation and emerging trends in semiconductor devices. And I think this is the one that I hope that you'll enjoy, because it talks about what's going on in the semiconductor industry right now, and specifically why are semiconductor devices important in our everyday life, and in solving some of the global problems that we have right now. That's not part of the textbook. It is simply there to give you motivation for the stuff that you're going to study in this class, and also perhaps give you some ideas on your course projects. We will get into module 1, which is crystal structures and electronic materials, 2 lectures there. By September 15th, I would like you to select your teams. So it seems like we have either 5 or 6 students in this class. If we have 5 students, then I think we're going to do a group of 3 and a group of 2 for the course projects. If we end up having 6 students in the class, we'll do a group of 3 and a group of 3. And if we have a group of 3, group of 2, I'll obviously take the lopsided size into account when I assign grades. I think the expectations will be a little bit more for the group that has 3 in it, 3 people. All right, so module 1, crystal structures, module 2, atomic structures and electronic configurations. In the past, these often take more than 2 lectures each to complete, but I'm going to try to move through them a little bit more quickly this semester than I have in the past. So I want your feedback. If you feel like I'm going too fast in these modules, I'd like you to kind of let me know and ask me to slow down. So that if you're having trouble following it. Most students are okay with the pace. Some students even say, oh, we could go a little bit faster. So I'm going to try that this semester, but if there's any issues, please let me know. Energy bands and charge carriers we'll get into by the end of September. Excess carriers in October. So by mid-October or end of October, we will cover modules 1 through 4, and these are the ABCs. These are the physics, like understanding solid state device physics, right? This is the fundamental understanding that you need to have to understand the second half of the course. And the second half of the course is going to be the devices themselves. Module 5 is on diodes, PN junctions. Module 6 is on MOSFETs. As I said, the most commonly used electronic device by far. Time allowing, we will get into module 7, just optoelectronics. Now, in terms of exams, there are 3 exams planned. So we're going to work our way backwards. First of all, so the final exam is, I have the wrong time here, I think. I have the wrong time. It's during our regularly scheduled class time, 5:30 to 7:30 will be the timing for the final exam. It's on the syllabus. Okay, so then if we go back to exam 2, I would like to have exam 2 about roughly a month before that. And that puts us at November 15th. And then about a month before that, I'd like to have our first exam, October 18th. So we have about a month and a half before our first exam, because there's a lot of material to cover here. So keep in mind that things, more like about 1 exam per month once we start getting into October, November, December. Now, in terms of the projects, I don't want the project to be a big burden towards the end of the semester, because I know at the end of the semester, you're going to have other courses that you're going to be dealing with. So I have this project calendar roughly here, is that start off early, like form your teams like in a week or two, right? Meet other students, see who you work well with, and decide on your teams. There's only going to be 2 teams, so it's going to be pretty straightforward here. By the end of September or early October, I want to see that you've selected a project topic, and then you can kind of work on it slowly. You know, your project outlines will be due, you know, after the first exam. So this is going to be a fair amount of work between the project proposal and the project outlines. So I'm giving you some time to do it. That project outline will be a detailed outline of the topics you intend to cover in your project, and even some of the details that you plan to include. We'll get into that later. Project draft. The project draft is going to be a fairly complete draft of your written portion of the project, so that before Thanksgiving break, you'll have most of your project written already, so that after Thanksgiving break, when things get absolutely nuts with your other classes, you won't have this hanging over you. At the end of this term, we'll do the presentations and the reports. The project is going to have 2 parts. Like, one is you're going to present the project to your class, and that's going to happen at the end of the term. And then you're also going to have a written portion, which is going to be about 8 pages. Working in teams shouldn't be too bad. So this is very important. The project draft and the project outline. Get this stuff out of the way earlier in the semester, so that this class isn't the one that's killing you at the end of the semester. Okay, and so that's kind of the rationale for how these deadlines are laid out. Project presentations will be in class December 8th. We need to have it on this date so that you have a week to study for your final exam. Okay, we could move these earlier too if anyone would like. You know, we could do them on the 6th or the first 2. I'm open to that as well. All right, so any questions or concerns about the course calendar? Okay, so these exam dates, just keep those in mind, keep those open, so that we can do that. So we avoid, you know, won't have to deal with any kind of makeup exam. As I said before, I generally don't do makeup exams, so those exam dates I would like you to keep open. Oh, I'm sorry. It looks like I have something in the chat window here. Okay, I wasn't looking at the chats. Okay, yeah, you're free to like post stuff on the chats if you'd like. All right, so we're coming up at 6:40 now. So I've spent a lot of time talking, and now I want to get to know. I want to get to know some of you. So let's go to this here. So what I'd like is for just take 5 minutes or so. I'm going to mute myself, and I would like for everyone to just fill out this questionnaire. Okay, just open up a Word document and write this stuff down. Word document or text editor, whatever you have on your computer there, and just write down some of these things, and then I'm gonna have a way for you to submit them after class. You're not going to be graded on this. This is just a way for me to know a little bit about you. All right, so first thing I'd like to, just include your name, maybe where you're from, if you like, what major you are, what year, you're an undergrad or grad student, PhD student. If you currently work, tell me a little bit about where you're working nowadays. I'm curious, and especially curious about like where our students are working, how this class might fit into your, your work life. And I also might be able to suggest something like based on where you work and what your topics of interest are, I could help you suggest project topics for you. Next is career goals. Where do you plan to go with your career right now? Not, I'm not going to hold you to it. I'm not going to check in with you 10 years from now, but like, having some goals, maybe you want to become, you want to climb up the corporate ladder and become a manager. That's like kind of like more like what type of position you want. But I'm also interested in like, what area do you want to work in? Do you want to work in automotive? Do you want to work in solar energy? Do you want to work in space and go like build rockets for Elon Musk? That's what I would do if I had to give up my Wayne State job. I'd probably just go try to build a Mars rocket. Do you want to get into like data science, or do you want to like build the next generation of semiconductor chips for Intel? Like that kind of stuff. Why do you plan to take this class? I'm assuming that why you plan to take this class hopefully fits into your career goals, but it might not either. Like a lot of people take this 4570 as a required course, and a lot of students just say like, I'm taking that course because I'm required to, and that's fine too. So just want to get to know that. I'm going to add another one here. Have you taken 4570 or other semiconductor class? That will help me know if, how fast I can move on the introductory material. And then the next 4 questions are the ones I'm most interested in. You don't have to write an essay for these things. Like literally just like tell me a little bit about yourself in these areas. Like one aspect of semiconductors you're interested in, future advancements, photovoltaics, like fabrication processes, IC chips, like machine learning applications, neuromorphic computing. Just tell me about something in the area of semiconductors you're interested in. I know that we haven't covered topics, so you may not know yet, but just, so throw in something. The next questions have to do with online learning, because I want to make this experience, I try to improve the experience as much as I can. And if I can get input from students, it's great. So that, we're kind of all in this together. I want you to learn, you guys want to learn by being in this class. So I'm looking for a little bit of your guidance here, honestly. What do you like and dislike about online learning? So tell me like one of the things you like and one of the things you dislike, so we can talk about that. What is your most successful study strategy for online learning that you found over the last year or two? I'm interested in knowing what has worked for you personally. And the last question is, what do you think is an effective teaching strategy that a professor has done? This could be, I'm assuming a lot of it's going to be for online learning, but even if it's not an online thing, if it's something else, some kind of strategy that you've seen a professor has done that helped you out. Okay, it could be something that happened recently. It could be something that happened when you were, much younger, maybe in undergrad or even high school. I don't know. So these are the things. So I'll go ahead and give you 5 minutes or so. Just write out those things, and then we'll just go through. We'll go through the 5 of us and discuss them. So I'll just mute myself for a few minutes, and then we'll get started again. Oh, and of course, any questions, if you have any questions about these questions, let me know. All right, great. So let's go. I'll start. Why don't I start? So as I mentioned, my name is Amar Basu. I'm originally from Troy, Michigan, which is 20 minutes north of Detroit. Many of you know that area. And my parents originally from India. They moved here in the 70s. But I grew up here, and I studied electrical engineering as an undergraduate. I went on to do a PhD in electrical engineering in the circuits and microsystems area at the University of Michigan, and I graduated in 2008. I also did a degree, dual master's degrees in electrical engineering and biomedical engineering. So the area of research that I currently do is in sort of the intersection between electrical engineering and biomedical engineering. So I work on wearable sensors for health monitoring. I work on computer vision devices for drug discovery. So drug discovery is an area of, like, let's say COVID happens. Let's say COVID happens and we need to quickly find antibodies for the COVID virus. Antibodies are what your body, if you inject someone with antibodies, they can, it's the beginning of your system's immune response to be able to fight off that infection. So antibody-based drugs are very important. So one of the things that I'm working on right now with a startup company is to build a really high-speed computer vision device that is used for identifying cells that secrete antibodies of interest, like biological cells. Okay. Other areas I work in is in microfabrication and microfluidics in general. So microfabrication is like the science and technology of making really small things. This at Wayne State, we recently were approved from a big grant from the National Science Foundation that we're going to get a 3D printer that prints devices at sub-micrometer length scales. So at length scales similar to what today's transistors are being fabricated at. So we're pretty excited about that. So those are some of the areas that I work in at Wayne State. In terms of career goals, I mentioned to you that if for some reason I lose my job at Wayne State, I'll try to go work for SpaceX. But I'm here at Wayne State. I'm currently a faculty member, and I just received a promotion to full professor this year. I've been at Wayne State for the past 10 years. I do a combination of research and teaching here, and I also work with the startup company to commercialize some of the technologies that I'm familiar with. I have been teaching this class for 10 years now, and I enjoy teaching it. And I hope to improve it. I hope to improve it like as I go. So that's what I want your feedback on. I have a background. I've been teaching 4570 and 5550 for the past 10 years. Not quite, I haven't taken the course. I took a similar course when I was a grad student. So some of the aspects of semiconductors that I'm interested in is I'm interested in how semiconductors can be used for biological measurements. As I mentioned, like one specific example is how can we use semiconductors to build wearable sensors like your Fitbit, the Apple Watches. There's a sensor that we're working on right now in my lab to detect something called orthostatic hypotension, which is something that other devices don't currently do. So using semiconductors to detect health conditions and to do health monitoring while the people are at home instead of at a hospital. Some things that I dislike about online learning, I did mention them to you already. Some of the things I dislike is that the engagement of students, like being able to see people face to face and being able to like write down things on a chalkboard or paper and just to kind of like work near each other. I feel like there's a lot of information exchange that happens there that is there's a little bit more of a barrier when you're trying to do everything online. The tools have gotten a lot better, but there's still a bit of a barrier. So I want your help in trying to make this class as interactive as possible. Something I like about online learning is that the convenience. I know that a lot of you work, so it's convenient to be able to teach from wherever you're at. So some of my most successful study strategies for online learning, as I said, I took a statistics course this year. I think it's super important to be an active learner. So the biggest mistake that I think that you can make is just to watch the lectures. Just sit down and watch it on your phone or watch it on your computer screen and not be doing something actively. So the way to actively learn something is to have a tablet out or have a piece of paper and a pen. As you're watching something, write stuff down, write notes to yourself. If, after the lecture is over, if you want to like rederive some of the concepts, do that. The most important thing, like the most important study strategy, look it up online. It's called the Feynman technique. The Feynman technique. And some of you may know about it already. A show of hands, anyone know about the Feynman technique? Oh, no one knows. Okay, well, that's fine because I can explain it. You do a Google search on it. You'll see that what it is basically a technique that Richard Feynman came up with. He was a Nobel Prize winning physicist. He was also incredibly acutely talented at being able to explain very, very difficult concepts in a way that's easy to understand. So he's an incredible teacher. And his technique on learning things was basically to learn something, to write down the name of the topic. It's a few step process. The first thing is you write down the name of the topic that you're trying to understand. Okay. And the second thing you do is you try to explain it to a fifth grader. You try to explain that concept to a fifth grader. Okay. And at the fifth grade level. And if you don't have a fifth grader in front of you or a person in front of you, look in the mirror and explain that topic to yourself as a fifth grader. You will find out that if you don't understand a topic and you can't explain it to someone in simplistic terms as a fifth grader, that means you don't understand the topic well enough. So the third step in the process is to go and figure out the holes in the gaps in your understanding, which prevented you from explaining it well to a fifth grader. Fill in the gaps and fill in how you're explaining it to someone. When you teach, when you explain something to someone else, you will end up understanding that material 100 times better. Okay, so that's basically the process. The step 4 is you just repeat. You just repeat this until you understand the material. So this is one example of active learning. And the Feynman technique is extremely helpful if you want to try to learn stuff very, very quickly. So that's a successful strategy. What do you think is an effective teaching strategy that a professor has done? Students have told me that like putting my lectures online have been very helpful. So anyway, so that's enough about me. So let's go through one by one. Maybe we can start at the top with Clayton. So how about we do it this way? Like, let's answer the first few like this. We'll just go through really quickly for everybody in the class. And then we'll spend the last part of class just discussing this as kind of like a panel, if you will. Like people will just throw in their opinions. So go ahead, Clayton.
So yeah, I live in Clawson now, and I'm from Brighton. I am a materials science and engineering major. To be honest, I don't know what year I am. I'm a grad student. I have a year left, but I've been taking classes like 1 or 2 at a time. So
great.
I work at Ford currently in the electrical systems engineering department as a core systems engineer.
Oh, excellent. Congrats.
Yep.
Sounds like a good job.
I actually just started like a few months ago and in this
Great.
position. I was in manufacturing before. So
great.
Yeah, I guess career goals are to stay in my job right now. And I'm taking the class because obviously it applies to electrical systems. And have I taken other semiconductors? I took semiconductors in undergrad at Michigan Tech, and I also took photovoltaics at Michigan Tech.
Oh, great, great. First of all, glad to hear that you went to Michigan Tech. Tech is a great school. Great school. And also the fact that you're a material scientist taking this course, we have had students from MSc take this course. Every semester we have students who take this class. And most of them have done very well. Because I don't know, your department is very good. So I've been quite happy with the students in material science. So great, nice to meet you, Clayton.
Yep, you too.
Corey.
Yeah, hi. I am from Cleveland, Ohio originally, but now I live in Oak Park, Michigan. And I'm a material science graduate as well. I think my year is 2024. And I currently also work at Ford, but I work as a materials engineer. And I work with systems that include mechatronics like handles, locks, and mechanisms.
Cool.
My career goals right now are to, eventually get into more of a supervisor management position, but right now I'm just trying to get better at what I do. I've been hired in as a Ford Direct for 3 years and worked there for 5 years. So.
Oh, excellent.
That's kind of
yeah. That's great. That's great. Yeah, and what was I going to say? So there's I think there's a lot of change happening at companies like Ford with the electric vehicles, new materials, things like that. So I think it's an interesting area to be in automotive. I know a lot of our graduates end up working in automotive, and I think there's going to be a lot of interesting stuff happening in the field with autonomous vehicles, electric vehicles, and things like that.
Absolutely.
Yeah. And then have you taken the semiconductor physics course before?
It was a long time ago. It was probably close to 10 years ago. So.
Okay.
Yeah.
Don't worry. We'll cover it again.
Yep. All right. Sounds good. Thanks.
Great. Nice to meet you, Corey. So right now we have 2 material scientists and no electrical engineers. So Melvin, hopefully you can break the balance here.
I guess I'm breaking the balance. So yes, my name is Melvin Edwards. I'm originally from Pontiac, Michigan, but I'm currently living in Redford, Michigan. So right now I'm going for my PhD in electrical engineering. I have a few more credits to complete in master's, but I plan on hopefully I can get my master's degree while I'm going for my PhD, which I believe I will be able to. Have to speak with
you will.
Dr. Rusky. Yeah.
Oh yeah. You'll definitely get your master's degree on the way.
Yeah. And I'm currently at ZF, working as a electromagnetic compatibility validation engineer.
Great.
Yeah, I mean it's okay. It's just more so like, it's more so just testing and everything. I kind of want to get more into like design. And that's kind of like more so my motivation for taking this course is so I can have a deeper understanding in my research, which is more geared towards CMOS analog, CMOS design. And I've done layouts and CMOS and everything like that. So I kind of want to have a deeper understanding of the device physics that I'm actually working with.
Great. Yeah, I think you'll get that. You'll definitely get that in this class.
I mean, I do have I guess I do have a I have a familiarity with this subject because I took the course, I believe, like 4 years ago.
Yeah.
So I'm familiar with it. I don't remember everything, immediately, but a lot of the things like, oh yeah, I do remember that. Then I'll hopefully be able to pick things up a lot quicker. And my second reason for taking the course, of course, is that I have to take the qualifying exam, and this is one of the topics that I'll likely be choosing.
Great.
And yes, I guess, I answered that one. I did take the 4570 class.
Good. All right, well, good to have you in the class, Melvin.
Thank you.
And Ali, let's move to Ali.
Hi everyone, I'm Ali Al-Damer and I'm from Kuwait. I'm doing a master's in electrical engineering, and hopefully this will be my last semester.
Cool. We
Um,
have someone from Kuwait. That's exciting.
and
That's
I do not
great.
work right now. My career goal is to work as a field engineer in like power station or like an oil industry in the future.
Hmm.
And I have taken a semiconductor class when I was taking my undergrad.
Excellent. Excellent. So Ali, this is going to be very interesting having you in the class. I think that you're going to bring a unique perspective. Very excited to have you here. The semiconductor devices, as you probably know, are becoming very important in power applications.
Yes.
Like for example, in smart grid, photovoltaics for renewables, and even in like the whole electric vehicle revolution, power electronics and power electric semiconductor devices are becoming very important in like things like charging stations and all the tech that basically drives our world. So
Everywhere.
yeah, excellent. Prakash.
Hi everybody. My name is Prakash. I'm from Wixom, Michigan. It's near Novi, Michigan, and I just finished my undergrad, and this is my first year as a grad student. And in terms of work, I'm currently working at Leidos under substation design group. And this is actually my second week, so pretty new there.
Oh, congratulations.
Thank you. In terms of career goals, I want to work at Tesla, so that'll be interesting. And why did I plan to take this class? So it goes hand in hand with the next question. So I took 4570 recently, and I really liked that class. So which is why I wanted to take this class, because I felt like this class built off the other one. So I want to take this class. Thank you.
Okay, sounds good. Awesome. Thanks. Nice to meet you, Prakash. And so I figure in the last 5 minutes of today's class, we can just talk about let's talk about these 3 or 4 questions in turn here, because I'm very curious to know. I know that many of you you're going to write this out, and I'm going to be able to look at it in your submissions. Now you'll be able to submit it on Canvas. But let's just talk about a few of these things. First of all, aspects of semiconductors you're interested in. We heard a little bit, like Ali mentioned, about power. The potential importance of power in semiconductors. So if any of you are like super interested in a particular aspect of semiconductors, tell us about that and why.
I guess I'm kind of interested in the vehicle/battery application just because it's my job. So it would help to, know more about it.
Vehicle and battery applications. Okay. So there's some interest in like solid state semiconductor like based batteries, or the use of I think there's one video that I'm going to have you guys send you a link to, and you can watch it over Labor Day weekend. And it's about the global shortage in semiconductors for, automotive companies aren't able to make cars right now because of the semiconductor shortage. So I think that you'll appreciate that. I think that'll be interesting.
I get emails on that like every day.
Yeah, I mean, there's tons of videos on it too, but I was hoping that we could all watch it together in today's class. But I'm just going to post a link to it. Maybe you all can watch it over Labor Day, and then we'll just kind of like discuss it in class next time. This is crazy. If there's one thing that's happened this year during COVID that made the world realize how important semiconductors are, it's this global semiconductor shortage right now. It's crazy. Okay, anyone else want to comment on aspects of semiconductors? Okay, let's move on to the next question then. What do you like or dislike about online learning?
I guess for me, my main thing is, it's easy to go from one class to the next. You can, there's no having to get up and walk to another class. So whereas other situations where you couldn't take a class that ended at, let's say, 7 o'clock, and then another class that starts at 7:05 or something like that. Just for example, online, that's definitely doable.
Yeah,
Because it only
definitely.
takes minutes, really, or even less than minutes, really.
Yeah, I've gone from meetings into class in like 5 minutes. It's kind of great, actually.
Yeah.
Great, thank you for that input. How about someone like something you dislike about online learning? Maybe someone else.
I think you've already said it, but the lack of in-person interaction and engagement
Yeah,
is kind of lost on the online format.
absolutely. Any ways that you found to get around that? Or maybe in your other classes?
Exactly. Yeah, I mean, some of the other, like this is kind of skipping to the other, the last question here, but
Yeah, that's okay.
some professors are a bit more like assertive and kind of searching for answers from students, in the middle of the lecture, and I think it kind of helps to keep engagement, but again, that kind of puts a little more of the burden on you rather than the students being assertive, but
Right.
yeah. So,
I'm happy to do
so.
that though. I've found that I actually have some slides that are basically like question slides. Like, and I ask the students, like, tell me your understanding of this. Because otherwise, I guess it's just watching a lectures. It's convenient, but it can get boring.
Right.
So how about someone else? Like maybe someone else, like something that's been a challenge with online learning, and maybe some kind of teaching strategies or like a teaching strategy that's helped overcome that. Or it could just be like a teaching strategy in general that's worked.
In general, like going through problems in class, I think it helps a lot.
Okay. I'm gonna note that down. Okay, I'm gonna put both of those things down here. So we will be doing some problem solving in class. We'll make sure we do enough of that. And Ali, if you find that the amount of problem solving that we do in class is not enough and you'd like to go over more problem solving in office hours, we can definitely do that.
Okay.
Yeah. There are some tricky problems that we'll be doing in this class. Okay. Yeah, someone else. How about like, a successful strategy for online learning that you've found works for you?
For me, Professor, I like turn off my phone so that I don't have like distractions sometimes.
Yeah. Yeah, that definitely helps.
Really like the online recordings and stuff that the teachers have because it's easier to go back and review lectures.
Yeah.
You don't always get that with an in-person class.
I agree. I like that a lot. You don't understand something, just watch it again. Yeah, I like that. What else? Like maybe just a few more minutes. I know we're just about over class right now, but just like maybe like just a little bit more input from one or two people. It could be any of these three topics. What do you like or dislike about online learning? Good study strategy that you've had, or a teaching strategy that the professor has done?
I feel like I guess like a teaching strategy, like I usually do well when it's like we review everything kind of generally, and then I take like there's like problems or something to solidify it, whether it's just a problem in the lecture or at home or whatever.
Okay. Yep, that sounds like a good strategy. In fact, I found that with the statistics class I was taking in Coursera over the summer. I watched the lectures, thought I understood it, and lo and behold, when I started doing the questions, that's when I really start to understand it.
Professor?
Yes.
I was also gonna say that working with like other person like groups or like I mean we can't really work in groups because we have like 6 or 7 people here, but working with a partner or also helps because like you get a different perspective and you learn from another.
Most definitely. Most definitely. I encourage everybody in the class to work together. I'm assuming you all have each other's contact. Do you all have each other's contact information? Maybe not.
I think you might be able to get it on Canvas, but I'm not sure.
Okay, let me know if you are or not, if you're able to see it or not. Like it should be in the groups thing on Canvas under people. Or if you, I'll just look here. If you're able to access this, you'll be able to see the other students in the class. And if you're not able to, let me know. And then I can pass around whoever's contact information we need. Because I would like for you guys to be able to work together. So, at Wayne State, we have like, you can use Zoom, of course. We also have Microsoft Teams. As you can log in with your Wayne State Teams account, and then, you can have chats, you can have virtual meetings, you can share files, you can create groups, you can create your own teams. Like, for example, like I have a bunch of teams for the group projects that I'm involved in. So it's a nice way for you to be able to communicate with other folks. And Zoom, of course, is great too. Okay. Well, it seems like we're just about out of time. I do want, like, next week's lecture is going to be about the importance or the impact of semiconductor devices in the industry. We're going to be talking about a lot of different areas, like the current trends in digital computers, importance of semiconductors and high density data storage. We'll talk about Moore's law and the computing revolution. I think you'll find it a pretty fun lecture. It's basically going to be about like the role of semiconductor devices in modern electronics. So this is something I do every semester, and I think that one thing, just watch this video. I'm going to send this to you, and the video is about the global chip shortage. Okay, and you'll see like why semiconductors are so important. With some of these videos. Okay, so thank you for staying a few extra minutes today. I'll stop the share right now, and we will end the lecture here today. Thanks for joining. And if there's any questions, I will stay on to answer any additional questions. But at this point, you can feel free to log off if you wish, and I will see you next Wednesday.
Thanks.
Thanks, Professor. Have a nice day.
Nice meeting you all.
Thank you. Sorry, how did you want us to send the Word document to you?
Oh yes, I will. I'll send an announcement about that since some people have logged off. There'll be you'll be able to submit the assignment on Canvas here. So I'll open up that assignment and you can just submit the Word doc online.
All right, thank you.
Yep, sounds good, Corey.
Thank you, Professor.
Thanks, Ali. Great to have you joining from Dubai, from Kuwait.
Yeah, thanks. It's great to be in your class too.
So are you in a different time zone then? Like, what time is it over there?
It's like 2 a.m.
Oh my gosh. So you're gonna have to drink coffee to get through this class, huh?
Oh, I just like changed my sleeping schedule because I'm a full student. So yeah.
Well, I also stay up until 2 in the morning, usually. So good, Ali. Like, look forward to seeing you next week.
Thanks.
All right, take care. Did you have any questions for me?
No, I just wanted to ask how should we submit it, but the other guy already asked.
Okay, awesome.
Thanks.
Thank you, Ali. Talk to you soon. Bye-bye.